Volcanoes, Earth's fiery giants, have fascinated and terrified humans for centuries. But have you ever wondered what really powers these awe-inspiring natural wonders? What is the driving force behind their explosive eruptions and the dramatic landscapes they create? Prepare to be amazed as we uncover the incredible forces that shape our planet and reveal the powerful connection between volcanoes and the shifting plates beneath our feet. Join us on this journey to explore the fascinating world of plate tectonics and discover how it influences the formation and behavior of volcanoes. It's time to ignite your curiosity and explore the science behind these geological giants. Tectonic activity, the engine of volcanic activity. At the heart of every volcano lies a fiery furnace, fueled by the relentless energy of tectonic activity. These massive slabs of rock that make up the Earth's crust are in constant motion, driven by the heat emanating from the planet's core. As these plates collide, converge, or pull apart, they release tremendous forces that have the power to shake our planet and create some of the most spectacular geological features on Earth, including volcanoes. Divergent plate boundaries, where new Earth is born. Along divergent plate boundaries, the Earth's crust is pulled apart, creating gaps that allow molten rock, also known as magma, to rise to the surface. As the magma cools and solidifies, it forms new sections of crust, resulting in the creation of mountain chains and volcanic activity. A prime example of this process is the Mid-Atlantic Ridge, a vast mountain range that stretches over 60,000 miles across the Atlantic Ocean. This underwater mountain range is the result of tectonic plates pulling apart, allowing magma to rise and solidify, creating new sections of Earth's crust. Convergent plate boundaries, where giants collide. Convergent plate boundaries are where two tectonic plates collide. The subduction of one plate beneath the other can cause immense pressure and heat, melting rock and generating magma. This magma then migrates upward, creating towering volcanic structures. The Pacific Northwest is home to the Cascade Volcanic Arc, a series of volcanoes formed due to the subduction of the Juan de Fuca microplate beneath the North American plate. Mount St. Helens, Mount Hood, and Mount Rainier are among the volcanoes in this arc that have shaped the region's landscape through volcanic activity. Volcanic arcs and the Ring of Fire. Volcanic arcs are chains of volcanoes that form as a result of convergent plate boundaries. The Pacific Ring of Fire is a prime example of this phenomenon, featuring prominent volcanic arcs such as the Mariana Islands, Japan, and the Eurasian Islands. These volcanic arcs are created when an oceanic plate collides with the continental plate and is pushed beneath it. The intense heat and pressure cause the rock to melt, forming magma that eventually erupts and builds up over time, forming volcanic chains. Hotspots. Localized areas of volcanism. Hotspots are areas of volcanic activity that are not associated with plate boundaries. These localized areas are believed to be caused by plumes of hot magma rising from deep within the Earth's mantle. As the hotspot remains stationary while the plate moves over it, a trail of volcanic activity is created. The Hawaiian Islands are a classic example of hotspot volcanism. The islands were formed as the Pacific Plate moved over a stationary hotspot, resulting in the creation of this volcanic archipelago. The anatomy of a volcano inside the fiery mountain. To understand how volcanoes work, it's essential to explore their anatomy. A volcano typically consists of several key components. The magma chamber is the reservoir of molten rock beneath the volcano. As magma accumulates in the chamber, pressure builds up. When the pressure exceeds the strength of the surrounding rock, an eruption occurs. The vent is the opening through which the magma erupts. During an eruption, the magma, now called lava, flows down the volcano's slopes through channels called lava channels. The shape of a volcano is determined by various factors, including the composition of the magma and the amount of gas it contains. Some volcanoes, like Mount Fuji, have a symmetrical conical shape, while others, like Mount Vesuvius, have a more irregular shape. Types of volcanic eruptions: explosive and effusive. Volcanic eruptions can vary widely in their intensity and explosivity. Explosive eruptions are characterized by violent explosions that release vast amounts of energy and propel ash, gases, and rock fragments into the atmosphere. On the other hand, effusive eruptions are more gentle and involve the relatively calm outpouring of lava. The type of eruption depends on factors such as the viscosity of the magma and the amount of dissolved gases. For instance, Mount St. Helens' 1980 eruption was one of the most violent events in recent history, showcasing the explosive power of volcanoes. In contrast, the eruption of Kilauea in Hawaii in 1983 demonstrated the effusive nature of some volcanic eruptions. Volcanoes and their impact on the environment and humans. Volcanoes have profound impacts on both the environment and human societies. Volcanic eruptions can cause widespread devastation, affecting air quality, soil fertility, and local climates. However, volcanoes also play a vital role in shaping Earth's geology and ecosystems. Volcanic ash, for example, can enrich soils and create new landforms. Moreover, volcanoes have captivated human imagination and inspired art, literature, and culture throughout history. The awe-inspiring power of volcanoes has left an indelible mark on human civilization. From the ancient Greek myths about Mount Etna to the haunting tales of Mount St. Helens, volcanoes have been revered and feared in equal measure. Volcanoes and climate change. A complex relationship. Volcanoes emit gases that can influence climate. However, their overall impact on climate change is complex and depends on various factors. Volcanic eruptions can inject massive amounts of ash and gases into the atmosphere, which can reflect sunlight and cool the planet temporarily. But volcanoes also release greenhouse gases like carbon dioxide, which can trap heat in the lower atmosphere. Understanding the net effect of volcanoes on climate is crucial for comprehending the Earth's climate system's complexities. Exploring volcanoes, a journey into the Earth's depths. For those seeking adventure and scientific discovery, exploring volcanoes offers a unique experience. Visiting active volcanoes, such as Mount Vesuvius or Mount Bromo, provides a first-hand glimpse into the raw power of nature. Guided tours and research expeditions allow enthusiasts to witness the fascinating geological processes that shape our planet. Volcanoes in mythology and culture, tales of fire and legend. Throughout history, volcanoes have been shrouded in mythology and folklore. In Greek mythology, Mount Etna was believed to be the home of the fire-breathing monster Typhon. Similarly, the Aztecs associated Mount Popocatépetl with the god of the sun and rain. These myths and legends reflect the profound impact volcanoes have had on human cultures. The future of volcanic research, unraveling the mysteries. Ongoing research and technological advancements continue to unravel the mysteries of volcanoes. Scientists are working to improve their understanding of volcanic activity through sophisticated monitoring systems and laboratory experiments. These efforts are crucial for predicting eruptions and mitigating their potential hazards. Plate tectonics is a driving force behind the formation and activity of volcanoes. At divergent plate boundaries, the creation of new crustal sections along mid-ocean ridges results in volcanic activity. Meanwhile, at convergent plate boundaries, the subduction of one plate beneath another leads to the formation of volcanic arcs, like the Cascades. Hotspots create localized volcanic activity independent of plate boundaries. Understanding plate tectonics helps us comprehend the distribution and behavior of volcanoes around the globe. By studying plate interactions, scientists can better predict volcanic eruptions and assess their potential impact on our planet. As we continue to explore the Earth's dynamic systems, unraveling the mysteries of plate tectonics and its influence on volcanoes will remain a captivating frontier in scientific discovery. We've journeyed to the heart of the matter, uncovering the tectonic forces that fuel these awe-inspiring natural wonders. But our exploration doesn't end here. Thank you for joining us on this eye-opening adventure. If you're eager to dive deeper into the world of volcanoes and plate tectonics, we invite you to subscribe to our channel for more fascinating content. And if you found this video informative, please don't hesitate to give it a thumbs up. Together, let's continue to explore the incredible forces that shape our planet and ignite our curiosity. Until next time, keep asking questions, keep exploring, and keep discovering.